Hello. This optimization problem is for our business people. So Mateo owns a small company that makes souvenir t-shirts. He can produce the shirts at a cost of $2 a piece. That's our cost right there. So you always want to focus in on two things that we have. That's cost and our revenue. And our revenue is going to be made up by a price quantity function. So that the shirts have been selling for $5 a piece. And at this price, tourists have been buying 4,000 shirts a month. That's a point. So when they give you two pieces of info like that, we should put those in blue to represent our price quantity. They're giving you a point. And then it says Mateo plans to raise the price of a shirt and expects that for a $1 increase, 400 fewer shirts will be sold. Well, that's a slope. So what we're going to be doing is creating a linear equation off of that because they're giving us a point and a slope. And it says here, assuming a linear function, form the demand function in terms of Q. So we have Q and P. So what they're asking for is we want our price in terms of Q. And so slope here is M and B is our y-intercept. So if you think about it, Q is our X, P is our Y. And we have this. So now we can go back and plug our stuff in that we have. So for a 4,000 shirt quantity, the price is $5. And that would make our slope then equal to the change in P over the change in Q. Because our Y here is P and our X is Q. So Mateo plans to raise the price of the shirt and expects for a $1 increase. That's positive. 400 fewer shirts will be sold. So that's what this is. This is our change in P and this is our change in Q. And if you see the word fewer, you know that it has to be negative. Okay, now we can plug all this in and find our equation. So I'm going to use the y minus y1 equals mx minus x1. And so in this case, it will be p minus p1 equals mq minus q1. Okay, so this is p minus our price, which is $5. And our slope is negative 1 over 400. Q minus 4,000. So P minus 5 equals negative 1 over 400. Q plus 10. Because if we distribute that, it'll give us a positive 10. And then we add the 5 over. So P is equal to negative 1 over 400. Q plus 15. So just to have a decimal, we'll say negative 0.0025 Q plus 15. Now we always want to verify that this is true. So if we were to plug in a quantity of 4,000, the price should come out to be 5. So plugging that in our calculator, there we go, it's 5. And our slope is negative 1 over 400, so this is perfect. All right, now to make a revenue, all we have to do is multiply it by a quantity. So if you take the price and you multiply it by the number of units you sold, you end up with the revenue, all right? It's like if you sold it for $10 and you sold 100, you would end up with $1,000. So it's just price times quantity. So times it by Q. So all that really means is to increase each one by a Q. So that's Q squared plus 15Q, like that. All right, and then now, what are they asking? Well, of course he wants to maximize his revenue. So if we take the revenue function and take the derivative, we end up with negative 0.005 Q plus 15. Set it equal to 0, and we get negative 0.005 Q equals negative 15. So Q equals 3,000 shirts. So 3,000 shirts is what will maximize the revenue, but it didn't ask for the shirts, it asked for the price. So if we take our price function, plug it in, it'll tell us the matching price. See, what happens is as you increase the price, you decrease the number of shirts sold. So right now, right here, it says for a $1 increase in price, he expects a $400 shirt decrease. And this linear equation gives us that price quantity relationship. So if we plug this in our calculator, you can see that the price is $7.50. So what price should Mateo charge? $7.50. What that means is he's selling them for $5 and he's selling 4,000 shirts. But does not mean he's maximizing his revenue. He's actually selling them for too little. So if he increases the price to $7.50, he'll sell less shirts, but he's going to make more money in revenue. Okay, but let's actually see what's going on here with the cost and the profit. So if we go back to the cost, he says he can produce shirts at a cost of $2 a piece. Now the pieces are Q. So that would make our cost function in terms of Q just 2Q. And then now we can create a profit function in terms of that. Profit is revenue minus cost. So if we take our revenue function, which is negative 0.0, let's put that in blue so we can see it. Negative 0.0025Q squared plus 15Q. And then we're going to subtract our cost, which is 2Q. We end up with a profit function of negative 0.0025 Q squared plus 13Q. And so you can see this is just a downward parabola, which will give us a max. That's our shape right here. So we're going to get a max. So what's the next question? What price should Mateo charge to maximize profit? So if we take the derivative of the profit, we get negative 0.005 Q plus 13, and then we set it equal to 0 like before. Divide, and Q is 2,600 shirts. So since it's actually less than 3,000, then we know our price is actually going to be even more. So now if we take our price function, multiply it by plug in the 2,600, it will tell us our price. Put a line here so we can see the two are different. This is profit, capital P. This is price, lowercase p. So it's $8.50. So if he wants to maximize profit, he should sell it for $8.50. So this is his starting point. With all the information he's collected, $8.50 is what he should sell it for to maximize profit. Yes, he'll sell less shirts, but that also means that he can carry less shirts too. 2,600 shirts instead of 4,000 shirts. And he'll sell them for $8.50, which will give him a maximum profit of $16,900. So he'll sell 2,600 shirts at $8.50, $16,900. And so you can see if he sells less shirts or more shirts, his profit is not enough through here. You could even go back and look at his initials. So if I put trace 4,000, you can see we are here. So we only made 12,000. So by selling less shirts for more money, he will make more money. And there you have it.